I will talk about joint optimization for compressive color video sensing and reconstruction under hardware constraints. Compressive video sensing is the process of encoding multiple subframes and multiple channels into a single frame and single channel with controlled sensor exposures and color filter. After capturing, the color video is reconstructed from the single compressed image. We call the exposure control as exposure pattern, and the exposure patterns indicates an exposed pixel in white color and an unexposed pixel in black color. And the color information is captured in surrounding pixels using a color filter. By capturing the image convoluted time and color information, it can reconstruct the video exceeding the spatio-temporal resolution of the sensor. The reconstruction quality depends on the performance of both the encoding pattern and the decoder. However, the separately optimization of the encoding pattern and the decoder limits the reconstruction quality. This is because each encoding pattern has a decoder suitable for it, and each decoder has an optimal encoding pattern for it. Therefore, it is necessary to jointly optimize. Since the encoding is convolution and reconstruction is deconvolution, encoding and reconstruction can be represented by deep neural network. Therefore, by learning the encoding and reconstruction with the deep neural network, it is possible to jointly optimize like an auto-encoder. Then, by capturing using optimized exposure pattern and reconstructing optimized decoder, it is possible to reconstruct higher quality video. Currently, various coded exposure sensors for compressed sensing have been proposed. However, these sensors have hardware limitation to control the exposure. The sensor of left side does not have pixel buffer, and it can only single exposure in one frame. And, the sensor of right side has limited exposure control line, and it control the exposure per line. Therefore, the exposure timing of neighboring same color is similar, and it is difficult to capture the time change of the color in the Bayer filter. So, the color and temporal information is effectively compressed by the jointly optimized color filter and exposure pattern. Therefore, we propose a method for jointly optimization of color filters, exposure patterns and decoders for reconstruction under hardware constraints in compressive video sensing by using a deep neural network. The proposed network has a structure like an auto-encoder that learns a decoder that reconstructs color video with color filters and exposure patterns. It consists of two main parts, a sensing layer that optimizes color filters and exposure patterns under hardware constraints and a reconstruction layer that reconstructs a video from the captured images. The reconstruction layer is a fully connected layer of 4 hidden layers. The layer for optimizing the encoding has two types of weights, first one is binary weight that emulate the capturing and second one is continuous weight for calculating gradient. The binary weights are updated with the continuous weights considering hardware constraint. This is the reconstruction results for spatial constraint sensor. Left side is Bayer filter and right side is optimized color filter. An upper row is optimized exposure pattern and bottom row is random pattern. The result surrounded by a red square is the proposed method. It shows that block noise is reduced in optimized pattern than in the random pattern. This is the reconstruction results for temporal constraint sensor. Although it is difficult to see the difference in appearance, the proposed method has best reconstruction quality. In conclusion, compressive video sensing is a task to encode multiple subframes and multiple channels into a single frame and single channel with controlled sensor exposures and color filter, and to reconstruct the color subframes from the single monochrome compressed frame. Optimize both the exposure pattern and the reconstruction decoder of compressive video sensing using the deep neural network by considering hardware constraints. It is possible to capture image by a real sensor. That's all. Thank you for your attention.